Hi everyone, welcome back. We are working on the final section of 1.4 today. We're going to be sketching a piecewise defined function. Go ahead and first write the essential question at the top of your page. And the question is, how do I sketch a function that's composed of multiple functions, or in this case, pieces? I already have the first example set up, so go ahead. If you have graph paper, use that for your notes today, because we're going to be focused on graphing. First function that we have is comprised of x minus 3 when x is less than or equal to 0, and 2x plus 5 when x is greater than 0. So the whole point of a piecewise function is that you actually have a couple functions set up onto the same graph, and it's representative of this one single function. Now, it's based on the two domains or more that you might see. So in some functions you might have 3 of them. In this case we have 2, where this function only lasts up to 0 when it's x, and after 0 it's this function. Okay, so let's go ahead and set this up. We know that these two are linear functions. The first one is x minus 3, and the second one is 2x plus 5. I'm going to go ahead and start labeling these so I know what numbers I'm dealing with. So let's make a pretty decently sized graph. I would say at least 7 each way. 2, 3, 4, 5, 6, 7, 8. Okay. So the first point I want to start at here is the y-intercept, and that's negative 3. So at 0, we know that it's negative 3. And this is only when the domain is less than or equal to 0. So remember, along the x-axis is our domain, and we want it when x is less than or equal to 0. So I'm actually going to go backwards toward the negative region. So down 1 over 1, down 1 over 1. Here I have enough to go ahead and sketch in this piece of the function. Now notice here I used a closed circle, and that's because the domain is actually defined here at 0. At the next portion, though, we have to use an open circle because this function is actually not defined as 0. But we want to start our graph along that point. So here our y-intercept is 5, so count up 1, 2, 3, 4, 5. I'm going to put an open circle right there. Now from there we have a slope of 2, and I'm going to go up to 1, 2 over 1. Let's do it one more time just to make sure. So 1, 2, and then over 1. From here, I have another piece of this function going up this way. And just like that, you have sketched the two pieces of this single function. Notice that because of these domains, we have it kind of split up. They end up starting at different points. And that here we have a closed circle because this is where the domain ends. Here, the domain is not included, so it's actually starting just at like 0.00001. Okay? Now, if you weren't able to graph it using the y-intercept and the slope, you can always go ahead and use an xy table. However, doing that's going to take a lot longer, especially for linear functions when you really should be able to just graph them quickly. So I encourage you to use other methods before using an xy table. All right, we're going to go ahead and go to a second example now where I show you some non-linear functions. I'm going to call that for the day. So 2 f of x is equal to negative 2 and x squared minus 4. Negative 2 when x is less than 0, and x squared minus 4 when x is greater than or equal to 0. Once again, I need a coordinate plane, so setting that up. Now notice that my first function is actually just a constant. Because it's just a constant, we know that it's just going to be a line. So I'm just going to set this up real quickly. 2, 3, 4, 5, 6. All right. So f of x is equal to negative 2 when x is less than 0. So starting at 0, I'm going to go down here to negative 2. And because it's not defined at that particular domain, we're going to have an open circle once again. Then, because it's just a negative 2, I have a horizontal line going straight through negative 2. So that's the first piece of this function. The next one is x squared minus 4. Hopefully by now you guys recognize that this is just a parabola. It's a quadratic function, with this particular one starting off at -4. So 1, 2, 3, 4, closed circle. I need to move over into my positive domain because this one is defined at x is greater than or equal to 0. So the next best number I should choose is probably 1. So 1 squared would be 1, 1 minus 4 would be -3. If you prefer, you may use an XY table just to record that. So 1, -3. Let's go ahead and use another point for good measure. I'll use 2. 2 squared is 4. 4 minus 4 is 0. So that's my next point. And it's definitely looking like a half of a parabola, so let's go ahead and sketch that upward. And just like that, we have the second piece of this function, and it's pretty much complete. So, if all of these made sense, go ahead, move on to the Google Forms. Otherwise, replay if you need to. That's the end of 1.4. So you guys have a good day.